Hello, welcome back. This is another math video from Mr. Andrews. So boys and girls, we're going to look at this week's Math Daily Review. This is your notes and guide sheet. We did this in class, but it's good for us to see it again in case you forgot. So let's go through it. So number one is asking about prime and composite numbers. So what you need to remember is that prime numbers have only two factors, and composite numbers have more than two, so three or more. So 71 is an odd number. So with odd numbers, only odd factors work. So 71 is an odd number, so we don't need to try odd factors. What you can do is also use a multiplication chart. So, and I would do a reverse rainbow. So I know 1 times 71 works. So the next number I would try is 3. Well, 3 times 20 is 60. And I can count up from there. So I can go 63, 66, 69, 72. So 3 is out. 5 doesn't work because this number doesn't end in a 5 or a 0. 7 times 10 is 70. So 7 doesn't work, then 10 doesn't work. So now the only other number I can try is 9. And 9 times 8 is 72. So that doesn't work either. So when I do my rainbow, 3 is out. So that number is out. 5 is out. So another number that links with 5 will be out. And 7 doesn't work with anything. And 9 doesn't work with anything. So the only two factors I have is 1 and 71. So this is a prime number. So I can use multiplication facts, I can skip count, I can use a reverse rainbow to eliminate numbers. Okay, number 2, we're learning about equivalent fractions. So this is a pattern. So what you do with the pattern is look at the numerators separately from the denominators, and you see how much is each number going up by. So you could just count it out, 2, 4, 6, and then what's the missing number? Well, that's 2 more. That would be 8. And on the bottom, the denominators are counting by tens. 10, 20, 30, and 40 would fit. So 8/40ths is my answer. So I look for how much the numbers are going up by. If it's going up by 2, then I count by 2. If it's going up by 3, I count it by 3. Same thing with the denominators. I look at what each denominator is going up by or going down by. Sometimes the numbers can go backwards. So that's for patterns. For number 3, I want to find an equivalent fraction to this one that's already done. So it's 2 halves. Well, this whole entire circle is shaded in. Then I have to do the same here. And when I look at this fraction, I notice that it's cut into fourths. And all 4 parts are shaded in, so that would be 4 fourths. So you look for the shaded amount, and you shade in the correct amount. So if it was 1/2, let's say it was 1/2, that was shaded in. And I had this circle cut into fourths. How much would I shade in? Well, I would shade in half of this circle as well. So that'll be 2 out of 4. So that'll be 2 fourths. So it depends on the amount that's shaded and how many parts that make up the whole. And that's how you determine what the equivalent fraction will be. Okay, number 4, you're taking, this is expanded form. And you're going to make it into a numeral, which is standard form. So what I do is I take each digit. I know that this is a 4-digit number because this is the highest digit here, which is 7. And then my hundreds place is 3. So I separate that by a comma. And I don't have any tens listed here, so a 0 will hold the place. And then 7 1. So my number is 7,307. So you're changing from expanded form to standard form. Okay, number 5, write improper fractions as whole numbers. Solve. You're adding fractions. So 1/4 plus 1/4 plus 1/4. That's when you add fractions. The bottom number doesn't change. The denominator stays the same because you're adding each piece. So this is a 1/4, and here's another 1/4. And there's another 1/4, so I have 3/4 shaded. And 3/4 is my answer. I'll rewrite that over. Okay, now we get to word problems. Key thing with word problems, you need to underline. You need to make sure you know what it is that you're doing. A donation center received 154 cans of corn, 505 cans of peas, and 716 cans of green beans. How many cans did they receive in total? Well, all these are parts. So this is a part, this is another part, and they're all cans. They're all adding cans of vegetables. So I'm adding them because I want to know the total of all the parts. And then when you add, don't forget to, when you go over 10, you have to regroup and make sure you set it up. So I'm just going to set these up. Number 7, a grocery store needed 465 cans of peas. So I like to underline and write the numbers in. If the peas come in boxes with 2 cans in each box, how many boxes would they need to order? So they need these many cans of peas. The peas come in boxes with 2 cans in each box. So I'm dividing. And then I'll figure out my answer. Now, if I get a leftover, remember I have to round up because I need to know how many boxes. And I can't have a remainder as my answer. So don't forget that if you have remainders. But this is division. So look for that. Okay, there's some on the back. All right, there are 18 pieces of popcorn in a small bag. If a movie theater sells 89 small bags, how many pieces of popcorn would they have sold? So 18 pieces of popcorn come in a small bag. If they sell 89 small bags, how many pieces of popcorn? Well, one bag is 18, and I'm doing 89 of those. So it's 18 times 89. And then I like to set up my array. And then multiply everything out. And you can look at other videos to check out multiplication strategies. So that's how I set that up. And last one, Mike had 1,078 tickets. He had one at the arcade. He spent 546 tickets on candy and another 431 tickets on Crazy Goo. How many tickets did he have left? Well, that's subtraction. So you started with this many, and you spent this and this. So I would add these two to find out how much I spent. I spent 978, and then I will subtract that from 1,078. So I want to make sure my numbers are correct. Yep, and then I find my answer. So that's a 2-step problem. So when you're solving these problems, remember to underline, look for keywords, and then take your time and solve it correctly. Okay, until next time, good luck.